Hi, this is John Weisenfeld. I just want to give you an update on the Printshop model that I was building, or a simulation actually. I'm using AnyLogic Personal Learning Edition. I think this is version 7.3.1. You can get this from the website http://www.anylogic.com. What I've got is a agent-based model, and it's built to simulate the interaction of the print job with, say, the rate of submission of jobs, the type of jobs that are submitted, how many staff are in the print shop, how many jobs are a certain type versus another as a percentage, how many copiers you have in the print shop, and then how many copies per minute or impressions per minute that the copy shops can run. So without further ado, let's the program will compile the model, and at the end of this video I'll have some information how to download the model that you're seeing here in this video, and how to download some documentation for the video. So once the job is compiled, you can run it. It's basically built on top of Java virtual machine, so it's a Java simulation. Agent-based model means that every print job is an agent in the sense that it can act independently of other jobs, and it basically walks through the print shop. So it gets set up, and then it gets the copier, and it has certain delays, and we're monitoring how many print jobs show up in the queue, so in the line for the copier. That's kind of our major output to the model. So I'll click run here. So this is the Printshop model, and it's going to start. Notice that it starts April 5th at 12:09 a.m. That's model time, and model time is not directly linked to real time. And so you'll see we had our first job come in, and these jobs are coming from the electronic submission portal, so the website for the print shop. And so I'm going to walk through the model from left to right. This is the Pasco School District print shop model v1.0. This is an initial attempt at a model and a simulation. So first of all, I can turn up whether the jobs are submitted 1 minute apart or say 60 minutes apart. And so as you watch the model, you should see this number, that is the number of jobs, this little blue number here, coming in to the system at a much slower rate every 60 minutes versus every 1 minute, say. So when I turn it down, then we should get jobs at a quicker pace. So jobs then flow from the website, from that front end to the print job to a setup block. The setup block basically has a delay in it that requires an operator. So far there's one staff member in the print shop, and they are working on each job. They have to touch each job, and it takes maybe 0.5 to 1.5 minutes, but that's a distribution that might be more accurately represented by a mean job of like 1 minute setup time per each one. So now some jobs are starting to flow. On each block, what you can see here is this is how many jobs have come into the block, this is how many jobs have gone out of the block, this is how many people are busy with a job, and this is how many jobs are in a queue, in a line, waiting for that person. So if I were to, well, basically jobs are coming in every minute or so, and they're being handled fairly effectively. This plot down here is showing me how many jobs are lined up at the copier. So let's maybe keep an eye on this graph down here, but let me keep walking through. So I can dial in more employees working in the job shop, and it doesn't necessarily affect the queue for the copier. That might be as we expect, because the copier is not labor intensive in a setup or interaction sense. For the Pasco School District Printshop, we have daily and non-daily jobs. A non-daily job is basically a job that requires more than, say, 900 impressions, and a daily job is 900 impressions or less. So this little block right here is telling you how this is splitting out. So right now we're having way more non-daily jobs. Sorry, we have way more non-daily jobs than daily jobs. You can turn or adjust. For some reason, this simulation is going the other way. I can turn up the fraction of daily jobs to 0.9 versus, so 90% of the jobs are now daily jobs and 10% are not are daily jobs and 10% are non-daily. And remember, non-daily are bigger than daily. So you can see here the number of impressions. So far, out of 41 jobs that have come into the system, 5 were under 300 impressions. 8 were 300 to 600 impressions. 0 were 600 to 900 impressions. Seems kind of odd. And then 29 were more than 1,000 impressions. And that's basically just a guess at, those ones that are all 900 are greater than, are about 1,000 impressions as I've set it up. So now here what we've got is our queue has decreased dramatically for the copiers, and that's because I've turned down the size of the jobs. So if I were to turn up, in other words, increase the ratio of non-daily, large jobs, to daily jobs, smaller jobs, then I would expect the queue to increase again. This simulation is running over a 24-hour period. The Printshop right now, this model is running 24/7, which I realize is unrealistic, but that's what we're doing. So you should see now the queue increasing. One way I can impact the size of the queue for the copiers is to add a copier. Right now the Printshop is only running 2 copiers according to this model. If I increase it to 3, you should notice or immediately see a decrease in the queue. There we go. Remember, we're still running large jobs. I should see the queue change again if I increase it to 4 copiers. And of course, I have the slider set so you could have up to 8 copy machines. Depending on your Printshop or depending on our plans for the Printshop, that may be accurate, that may not be accurate. Okay, so we basically have the jobs coming in. They have some setup delay. They are broken down into 2 different major categories. We have an idea of how many impressions is in each job. And the last slider I'd like to talk about is a slider that sets the copier impressions per minute. So if you pay for a fancy copier, you of course can get large copies per minute. If you don't have that type of copier, then you may be back at, say, 50 impressions per minute. Sorry, let's keep it at 4 copiers, but turn down the impressions per minute to 50. We should see now that the queue for the copies increases. Even though there's 4 copiers, they're able to run copies much slower. And so we should see the queue increase here for the copy machine. The queue, again, is this number, this little blue number on the upper left of the run copies block. I can also increase the queue if I decrease the number of copiers that are in service. And there's a little bit of lag in the system. In other words, this shows you how many copiers are active. As they fall out of circulation, it doesn't automatically go to 2. In other words, there's some jobs on copiers that weren't in circulation. There we not yet. That should drop to 2 eventually. And if I increase the number of copies per minute, impressions per minute up, of course my queue will decrease. And if I increase the number of copy machines, my queue should increase as well. This is a pretty first guess type look at this model. In other words, the queue length on the copiers, or actually it's one queue for all the copiers, might not be as accurate. You might want to dedicate copiers to certain types of jobs, and you might want to then split out this flow, this logical flow of jobs through the print shop. I also have some other statistics that I'm gathering, which is maybe the mean number of clicks. That is, what's the average number of clicks, so impressions that a job has, the average elapsed time for each job, how many seconds or minutes are, I'm not clear on the units on this one, and then some job statistics. Let's see what the average job is taking. So the way these simulations are working is that you can look at one screen versus another. So my queue has basically risen to above 10, and so I think what I'll do is increase the number of copiers in service, and notice that my queue should immediately drop or start getting under control, at least, you know, under maybe 10 jobs waiting. Here's some notes for the model, and here are some on the other sheet there were some red notes, some implementation details for the model, but that's the basic idea. If you have any questions, my email is here in the model, in the simulation information here, and be happy to share with you what I'm learning from this exercise. Thanks for watching.